In the last session, we completed till the failure mode effect analysis, which is one of the risk management tool which we use in the improve phase. And now we are going to talk about the very important tool of the improve phase, which is called design of experiment. Okay, so this design of experiment is a tool which is very vast. It's a very vast subject. There are too many tools and techniques which are used in design of experiment. However, in a black belt program, we will be going to talk about the full factorial design. That's one of the types of design of experiment. However, if you want to study further, there are separate courses on design of experiment which are available. And when you enroll for your master black belt certification in the future, there you would also find a detailed 3 days class on design of experiment, which is around 12 to 15 hours of class on design of experiment. Today we are going to conduct design experiment probably in an hour's time, which is required for the black belt training and certification. Design of experiment is majority used in the research and industry, research and development, some bit in the manufacturing, very rare in the service industry. Reason because it's take a lot of time to complete, and usually in the projects that we would not have that much time. So that's why design of experiment is not very commonly used in the service industries. So let's understand first that what is design of experiment, what is the purpose of design of experiment in an improve phase. So let's understand in detail, and then we will discuss about some of the topics for design of experiment, how to conduct design of experiment on Minitab as well. So we will take that as well. So what is design of experiment? Design of experiment is that doing an experiment of certain things before implementing certain solutions. Okay, because sometimes the type of solution that we are implementing is very critical and very important in nature, that if I don't do any sort of an experiment, I will not be able to implement it. Okay, so doing an experiment of the design that we have come across is called design of experiment. Okay, wherein we use different permutation combinations, do a lot of try and testing, and come up with a perfect design that we should implement in our process is called design of experiment. So which means I do, let's say 10-15 experiments and come up with probably 1 or 2 designs that is most relevant for my project. So that is what we will be doing in design of experiment. Okay, so as I mentioned, it's a very big subject. We are covering a small portion of it. Just a warning that if you decide to try DOE, don't do it alone. Consult it with someone who has done it before. Okay, so if you don't have the practical experience doing it, please don't do it. Take a help of a mentor for doing design of experiment. There are some terminologies which are used in design of experiment, which I want you to be aware of, so that when we use design of experiment, you'll be able to refer to those terms. Okay, the first is the response. Okay, so we all know what is the response. Response is the why, the opportunity that we are working on. Okay, factors are the inputs or axis. It's an independent variable that may affect the response. So factors are the probably your causes, your axis that is impacting your response. Then we have levels. Okay, levels are the different variables that we have, like subgroups that we have. So one factor can have multiple levels. So likewise, if one of the factor is temperature, the levels could be low and high, or if there are more than 2 levels, then it could be low, medium, and high. So levels are basically the subgroups of the factors. Okay. Then another thing which we need to know is the noise factors. Noise factors are some of the uncontrollable reasons, some of the reasons that which might impact my design, which would not let me my design, which won't let my design completed, which is sometimes beyond my control. That is called the noise factor, as a name suggests. Okay, so we discuss response, we discuss factors, we discuss levels. Then replication. So for example, I have done design of experiment for 3 different factors and 2 different levels. Now I want to do the replication. I'm going to repeat the same experiment again. That is called replication. Okay, so I can do replication n number of times, because the more replication I do, the more confident I would be about my experiment. Then we talk about the runs. Okay, runs is very, very important. Runs are basically the number of trials that I'm going to have. Okay, there is a formula for run. Run is equal to level power factor. Okay, so which means if the factor is 3, level is 2, how many should be the run? Can someone answer that?
8.
8.
So
2 to power 3.
2 to power 3 is 8. So that is the number of runs. Okay. So once again, factors are my causes, levels are my groups, subgroups, different subgroups between those factors. Okay. Like factor is my temperature, and temperature can have different level, high and medium. If factor is 3 and level is 3, how many runs would I have to go for?
27.
27. Absolutely. And one more question. So if my factor is 2, my level is also 2, and then I have 2 replicas, then how many runs should I have?
4. Factor is 2 and level is 2.
So let's do the same here. Factor is 3. Okay, factor is 3, level is 3, and 2 replicas.
54 would be the answer,
27.
because we'll repeat the whole thing again.
Yes,
27
absolutely.
into 2. Okay.
So 27 plus 27, or 27 into 2 is 54. Okay. So that is the runs, which means how many such data points, how many such designs that I'll be coming up with. So I will be coming up with 54 designs, wherein I have to select one. That is called runs. Okay. So I'll repeat the formula. Formula for run is level to the power of factor. Okay. If I am doing only 1 replica, then it is same. If I am doing 2 replica, then I multiply it by 2. If I do 3 replica, I'll multiply by 3. Is it clear to all of you?
Yeah.
That is how we calculate the number of runs to do the experiment.
Simon, can we have different levels?
Can we have different levels for
Each factor? So let's say factor 1 is low and high, and factor 2 is low, medium, high.
Yeah. So Minitab give us an opportunity to do that. Yeah. If you have that kind of a combination, we can do the design of experiment in that way also. So what Ashwini is asking, that can we decide different levels for different factors? The answer is yes, we can do that. It is not compulsory that we say that each factor has same number of levels. So if each factor has different number of level, like factor 1 has 2 levels, factor second has 3 levels, and factor third have 4 levels. So that is also possible. Level has to be at least 2. It should not be less than that. Okay. So that is what is the runs. Okay. So there are major approaches to design of experiment. First is the factorial design. Then we have Taguchi design, and then we have response surface model. However, as I said, in the black belt training, we are only going to cover the factorial design, wherein we will cover the full factorial design and the fractional factorial design. Okay, so we'll be focusing on the factorial design during our training. Now let's understand the difference between full factorial design and fractional factorial. So full factorial design is the one which we just discussed, wherein I am coming up with every permutation and combination of different levels and different factors. Likewise, if I have 3 levels and 3 factors, I will be coming up with 27 experiments. Okay, so that's a full factorial, wherein I am taking everything into consideration, which is something which we just discussed, wherein we haven't taken off anything yet. However, in the fractional factorial design, the Minitab automatically randomly selects any random number depending upon the factors and levels. So for example, if I have 3 levels and 3 factors, for the full factorial, I have 27 runs, correct?
Yeah.
But for the fractional factorial design, depending upon the number of data points, it will come up with something lesser than that. This is done when the cost of running experiment is very, very high. When I don't have that much time, so randomly select that instead of 27, we should do 16 experiment or maybe 8 experiment. Okay. So it again depends upon the number of levels. It again depends upon the number of factors. So that is the only difference between full factorial design and fractional factorial design. In full factorial design, we come up with all the experiments which should be there, and in fractional, the Minitab automatically randomly comes up with the number of runs which should be there for fractional. So that's the only difference. So I will take a minute to check if the basic is clear with all of you.
Yes.
What about others?
Yes, Anna.
Yeah.
Yeah.
Yes.
So now let's take an example here, which you can see on the screen also. We are doing a project on the productivity. Okay, and now we are not sure that how we are going to implement the solution because we have a lot of combination. So the factors that we have is, we have 3 factors, means we have 3 causes: shift start time, number of breaks associate can take during the shift, and the third factor is feedback meeting. Okay, and there are levels to each of the factors. So shift timing ka jo factor hai, that is 8 a.m. or 9 a.m. Okay, number of breaks has 1 break or 2 break, and feedback meeting, which is 15 minutes meeting at the start of the day, either 1 or 2. Okay, so now we have 3 factors and 2 levels. Okay, so which means the total number of runs would be 8, and if I do the replica, then it would be 16. So this is an example that we are currently looking at. Is the example clear to all of you? It was very, very simple. But still, if you haven't understood, I can repeat.
Got it.
Okay, so this is an example that we have come up with, and now somebody should ask this question: that how is this possible? How should we come up with a conclusion? It's very, very simple. You're doing a project, you identified some of the causes, the main causes, which is called the main effect. So let's say during a project, some of the causes which are very, very critical, on which you want to do an experiment, wherein you have identified the solution as well, but you don't know which solution will it get implemented. I have certain factors, I have certain levels to it. Okay, so for that, I would have to come up with the design of experiment, that which of the combinations should I come up with to get to the design of experiment. Okay, so let me just open Minitab and show you how you can do that. Okay, just give me a second. And let's take an example of our choice, any example anybody wants to take, and then we can just change what we discuss. So I have the Minitab open in front of me. Okay, so I don't need any data beforehand to run the full factorial design or half factorial design or fractional factorial design. I can just go ahead. So I go to stats. Is my screen visible to all of you? The Minitab one? I've just switched it.
Yeah.
Great. So I go to stat, I go to DOE, which is design of experiment. I go to factorial because we are working on the factorial one, and I click on create factorial design. Okay, so stat, DOE, factorial, and create factorial design. So I click on create factorial design. It is asking that how many levels do you want? I said I want 2 levels. Okay, he's asking for how many factors should be there. I mentioned 3. So let's do with 2 and 3, and then I'll also show you if you want to change the levels also, how you can do it. So you can change the number of factors from here. You can have maximum 15 factors. Okay, because if you have more than 15 factors, then it becomes very, very complicated. So let's do it for 2 factors. Okay. Now click on display available design. So if I have 2 levels, okay, and I have 2 factors, how many should be the number of runs?
4 with 1 replication. Without
So
any replication.
without
Yeah,
any
4
replication. Okay.
without any
So, okay.
replication.
Okay, so I click on this, then I click on design. Okay, so I click on this one, then I have to click on factors. Okay, so it was already mentioned some of the things here. Let's do the new one here. So we have to define it. So let's come up with some factors here. Please, any factors, please take any opportunity and let's give a factors to it. Anybody? Let's see what different thing we can come up with. And let me do with 3. I think we should get more. So number of factors, I mean moving to 3. Okay. And we are doing a full factorial. Yeah.
Plant.
Please get plant. Okay. So one factor is
A or
plant. So plant A or plant B. Okay. So the type would be text. Okay. Shift timings or what you want to give? Shift timings?
Shift timing, or there can be 3 shifts, day, night, and 1 general shift.
So we have selected 2 levels as of now. So once we do the 3 levels, then
Morning.
That would
Then
be
it will be day and
morning,
night, morning and night shift.
morning and night. Okay. And third, any other factor you want to?
Break times.
Break timings. Okay. Please give the levels.
1 hour or half hour.
1 hour and 30 minutes. Okay.
That
So
will be text then, right? The
Yes.
type will become text.
Absolutely. So now I have given 3 factors. I'm saying plant, shift timing, and break timings is impacting my activity, let's say. Okay, could be anything which is impacting, and each has 2 different levels. So plant A and B, shift timing morning and night, and break timing 1 hour and 30. Okay, so I click on OK.